What's up, everyone? It's that math magician, and on this video, we're checking out exponents, and we want to see, can we use the laws of exponents to help us solve some exponential expressions? And we have two for us to do on this video. We have one where we're going to be using the quotient rule, because we have some variables being divided by each other. And then we're going to deal with the one on the right, which has 1 to the 0 power, and we got to review what it means to have something to the 0 power. So let's focus in on the one on the left. Notice that we first want to deal with the coefficients or the constants, basically those whole numbers in front. I have 16 being divided by 8, and 16 divided by 8 is going to be 2. So far so good, right? When we have whole numbers, we just need to do what we normally do for normal computation. I know we get stuck with all these laws of exponents in our brains, but don't forget, 16 over 8 is just 2. And if we want to get really fancy, we can even write 2 over 1, right? If we want to keep it in that fraction form. But really, it just simplifies to 2. Alrighty, we're going to go ahead and move to our x variable. Now look at this x variable. I have x to the 5th. I have x squared. Remember, our quotient rule says if we have one being divided by the other, we take the top exponent and we subtract it from the bottom exponent. So I'm going to have x to the 5 minus 2. And 5 minus 2 is going to give us x to the 3rd power. I probably should keep that in blue so we can keep track of what we did. Okay, remember, quotient rule says divide from the numerator exponent by the denominator exponent. 5 minus 2, it gives us 3. Awesome. Alrighty, let's do the next one now. We're going to change our color to red. We have to look at our y variables. Now look at the one on top didn't have one. So I put a 1 in to remind myself that for y, we're going to be subtracting 1 minus 4. And 1 minus 4 ends up being y to the negative 3 power. Now you might be thinking, okay, we're done. We got it. We simplified it. There's no more fractions. But no. We don't leave our answers with negative exponents. We don't like negative exponents. So we need to take care of that y variable. Essentially, what's going to happen is the 2 and the x cubed, that's going to stay the same. But that y variable, since there's a negative on it, we need to take the reciprocal of it, which means it gets flipped to go underneath the exponent. And since it's going underneath the, not the exponent, underneath the fraction, it ends up going underneath our 2 to the x cubed, but now the exponent is positive. This right here is our final answer. Don't forget, negative exponents, they got to flip to be positive, but you got to send it either to the denominator, or if it was already in the denominator, it shoots up to the numerator. You take the reciprocal. Awesome, really good. Now, we have this problem here that says 3x to the 0 power. And you might be thinking, oh, anything to the 0 power is 1. So the answer must be 1. That is incorrect for this guy. Okay, that is incorrect. It would be correct if the quantity 3x was to the 0 power, because then the whole thing turns into a 1. The 3x changes to the 1. I would agree for that. But for this, notice that the exponent of 0 is only on the x term. What that means is then is that we still have that 3 hanging out in front. Now the x to the 0, that's going to simplify to a 1. And 3 times 1 gives us our final answer of 3. Be very careful. I know it feels like, oh, a 0 exponent becomes a 1. But take your time. Really understand what has that exponent so you can simplify it correctly. Alrighty, y'all. It's that math magician, and I'll see you on the next video.